Hello there, and welcome to Science for Sleep, where curiosity floats like a feather and science tucks itself gently under the covers. Tonight, we set our sights not on the ticking of clocks or the beating of hearts, but on something a little farther away, about 600 light-years farther, give or take. Have you ever looked up at the night sky and wondered, what if there's another Earth up there? One with oceans that shimmer under twin moons, or clouds that glow a soft blue at dusk. A place not just beautiful, but habitable. Home-like, in a way we can't quite name. Well, there's a name astronomers have given it. Kepler-22b. It doesn't roll off the tongue like Eden or Home Sweet Home, but behind that name lies one of the most promising candidates we've found for a second Earth. Before we drift too far from our own blue planet, let me ask, where are you listening from tonight? What corner of Earth are you calling home for now? And what time is it there exactly? Funny, isn't it? We're talking about life on a world light years away, and yet this moment, this breath, still belongs to you, right here, right now. If you find these quiet voyages soothing, or simply a gentle way to end your day, I'd be ever so grateful if you gave the video a like, or maybe subscribed. It helps this little constellation of calm reach others, who might also be wandering through their thoughts in the quiet hours. Now, settle in. Let your thoughts unspool like starlight, because somewhere between solar winds and distant suns lies the story of a planet that just might be our next home. Let's begin. Sometimes when the world gets quiet, just before sleep or just after a sigh, our minds lift off from the surface of the everyday. They drift, not to the to-do list, not to the laundry, but out, way, way out. And maybe in one of those soft between-thought moments you found yourself gazing at the stars, not really searching for constellations, just wondering, what would it feel like to stand on another world? Not just any world, not a blazing, sulphur-choked rock like Venus, or a frozen gas giant like Neptune. No, a real world. A world like ours, with wind and maybe waves, with mountains that cast shadows at dawn, maybe even with the sound of the rain, though the atmosphere might carry it in a different rhythm. You wouldn't know the constellations overhead, the seasons would shift differently, but it would feel, somehow, familiar. That longing, that gentle ache beneath the ribs when you look up at a clear sky and feel, inexplicably, that Earth is not the whole story. That's not science fiction. It's psychology. It's human. We carry in us a strange blend of contentment and curiosity, a rootedness to this Earth, and a restlessness to leave it, to find something more, not because we dislike what we have, but because we sense there might be other variations of home written somewhere in the fabric of the stars. This is the emotional undercurrent of space exploration, not the rockets or the headlines or the politics, but the quiet idea that maybe, just maybe, we were never meant to stay in one place forever. And the moment we discovered Kepler-22b, that pale speck orbiting a sun not so different from our own, something ancient stirred in the modern mind. Hope, not the frantic, urgent kind, but the slow burning kind. The kind that glows gently as you fall asleep thinking, what if? There's something deeply strange about how easily we can imagine life elsewhere, isn't there? No one had to teach you how to picture an alien sunset, or to guess what alien trees might look like. Your mind just goes there, uninvited and wide-eyed, like a child in a museum. We imagine green fields, gentle rain, maybe a moon that hangs impossibly close in the sky, maybe bioluminescent forests or clouds that move in slow spirals, and beneath all of that imagining something simpler, the wish to feel small again, to walk under a sky that reminds us how much there is left to wonder about. There's a name for this, actually. Scientists call it the overview effect. It's usually described by astronauts who've seen Earth from orbit, that overwhelming feeling of connectedness, fragility, and awe. But I think we all have a version of it, even here on the surface, when we look up, when we imagine another world, when we feel the vastness and let it calm us instead of frightening us. We aren't just drawn to Kepler-22b because it's potentially habitable. We're drawn because it represents a mirror of Earth, seen from across the galaxy, a cosmic echo. The same way we might feel when we meet a stranger who, inexplicably, feels like an old friend. The truth is, you don't need to be a scientist to care about exoplanets. You just need to be human. You just need to have that tiny flicker of thought that whispers, maybe this isn't the only place life can bloom. And Kepler-22b gives that whisper something to hold on to. Let's talk about distance for a moment, not in kilometers or light years, but in feeling. 600 light years. That's how far Kepler-22b is from us. It's so far that if you somehow sent a message there right now, it would still be travelling long after you and I are gone. It would arrive centuries from now, whispering across a quiet galaxy to a world that perhaps never even knew we existed, and yet we feel close to it. Why? Because it reminds us of Earth. Not in exact detail. We don't yet know its mountains or rivers or whether it even has either, but in its rhythm, in its orbit, in its quiet compatibility. Kepler-22b orbits in what's called the habitable zone, the Goldilocks region. Not too hot, not too cold, just right for liquid water, just right for something like life, just right for imagining ourselves there. And so, from here, from this quiet room, this quiet moment, we let our minds step out into the dark, not in fear, but in wonder. We imagine building homes on alien shores. We picture children learning the shape of unfamiliar constellations. We think about a second Earth, not to escape this one, but to grow alongside it. Because as strange as it sounds, thinking about other planets can make us love our own more. You begin to realize how rare it is to have oxygen in the air, to have blue in the sky, to have trees that dance when the wind passes through. And so the question becomes less, why should we go? And more, how could we not be curious? You don't have to be a physicist to be moved by the stars. You just have to have looked at the ocean and wondered what's beyond the horizon. That's all space is, really. A bigger version of the same question we've always asked. What's over there? We've asked it across mountains, deserts, oceans, and now star systems. And Kepler-22b is the newest answer, or at least the newest maybe. It represents a profound kind of hope, not the frantic dash for escape, but the long, patient belief that our story isn't done being written, that perhaps, in a galaxy strewn with billions of stars, we're not the end of evolution's sentence, we are the comma. There's another psychological layer here, not just curiosity but continuity. To imagine settling on Kepler-22b isn't just to imagine going there, it's to imagine surviving, adapting, flourishing. It's imagining human laughter echoing on alien ground. It's imagining art, music, stories, all blooming again in new soil. Some part of us, even the quiet part, dreams not just of finding another Earth, but of becoming new Earthlings, of writing a second chapter in the human story. One where we learn from the past, bring our best forward, and grow into something gentler, wiser, more enduring. That's the psychological pull of a world like Kepler-22b. Not escape, but expansion. Not a second chance to run from our mistakes, but a chance to become more than we've been. And even if we never reach it, even if it's always out there, silent and unvisited, it will still have done something beautiful. It will have given our species something to look forward to, something to reach toward, something to dream of on quiet nights when the sky is clear and the heart is full. So if you find your thoughts drifting that way tonight, toward stars and silence, toward oceans that might not be water and skies that might be green, let them go, let them wander. Because imagining other worlds doesn't make you naive, it makes you ancient, it makes you human. And if we ever do set foot on Kepler-22b, if we ever breathe its air or build beneath its sky, it won't be because we solved every problem. It will be because we refuse to stop wondering, Because we looked up and saw more than stars. We saw home, waiting to be known. Long before telescopes traced paths through starlight, before science gave names to exoplanets and orbits, the night sky was a canvas for story. A whispering expanse full of signs, gods, animals, and unknowable things. For most of human history, we didn't peer into the heavens with instruments. We listened to them. We read them like a book written in shimmering ink. We looked up and saw not just stars, but meaning. And woven deep into those ancient meanings, one question quietly pulsed beneath the myths and constellations. Are we alone? The earliest cultures didn't speak of exoplanets, of course, but they dreamed of other realms, other worlds. The Babylonians, meticulous sky watchers and mathematicians of the night, believed the heavens were layered, stacked like invisible shelves. Planets were gods roaming those levels, each with their personality and purpose. Venus was Inanna, the goddess of love and war. Mars, the Red Wanderer, was Nergal, bringer of plague and protector alike. To gaze at the sky was to look into a divine ecosystem, alive, responsive, reflective of us. In ancient Egypt, the stars were the souls of the dead. The Milky Way was a celestial river, a Nile for the sky, where spirits floated after death. There was life beyond this one, not just spiritually but literally, out there in the stars. And in Polynesian cultures, the sky was not distant but navigable, a map, a memory, a whispering teacher. Pacific Island navigators could read the stars with astonishing accuracy, using them not just to find direction, but to carry history. They saw the night not as unreachable but as useful, a place of guidance. It's remarkable, isn't it? That in every culture, isolated by continents and oceans, the stars were always full of meaning, always speaking. In Hindu cosmology, there are lokas, layered realms or planes of existence, stacked like invisible dimensions. Earth was just one of many. In Norse mythology, there were the 9 worlds, branches on the great tree Yggdrasil. Some were realms of gods or giants, but others, like Midgard, our world, weren't unique. They were part of a system, one among many. Even the ancient Greeks, philosophers of stone and shadow, imagined a multiverse, a plurality of worlds. Democritus, a philosopher born in the 5th century BCE, wrote that there are infinite worlds both like and unlike this world of ours, some with suns, some with moons, some teeming with life, others barren and silent. Thousands of years before the Kepler telescope whispered its first discovery, humans were already imagining the exoplanet. We didn't know what to call it. We called it the heavens, the other realms, the beyond. But the longing was already there. The intuition that this earth, this single bright marble, was not the whole story. The Jewish mystical text Zohar described countless worlds that circle above. The Quran references 7 heavens, layered and vast. Early Islamic scholars in the golden age of science debated the possibility of other inhabited worlds, not metaphorically but scientifically. Al-Farabi, the polymath philosopher, mused on the existence of multiple Earth-like worlds long before telescopes were born. In China, the night sky was not just beautiful, it was administrative. An entire celestial bureaucracy existed in their imagination. The sky mirrored the state. But beneath that metaphor was a practical truth, the belief that the heavens were vast and patterned, that their complexity mirrored our own. The Mayans tracked celestial bodies with astonishing accuracy, predicting eclipses and solstices down to the day. But they also believed the stars told stories, not just of gods and cycles, but of destiny. And in their vast calendars spanning thousands of years, there was always an openness to cosmic movement, change, return. Because here's the thing, humans have always imagined more than one Earth. We didn't always call it Kepler-22b, but we dreamed of it, intuited it, whispered about it around fires, painted it in myths, and saw its shadow in the shimmer of stars. And this wasn't just about astronomy. It was about home, about belonging. Many cultures have creation myths where humans come from the stars. The Dogon people of Mali tell stories of beings who descended from Sirius, the brightest star in our sky, to teach them. These were not metaphors. These were inheritances, passed down through generations. The sky was not just a place. It was a memory, a return point. In Native American traditions, stories often speak of star people, ancestors from beyond, sometimes visitors, sometimes reflections of ourselves. And if we pause gently, without the rush of skepticism, we begin to see what these stories were doing. They weren't predicting space travel. They were feeling something we still feel now, that quiet sense that the cosmos is not empty, that it is filled with rhythm, with memory, with possibility, that something is waiting, not in a science fiction way, but in a spiritual one, a kind of cosmic hospitality. And so, when NASA announced Kepler-22b in 2011, many people were captivated not because it was scientifically viable, but because it sounded like a familiar idea, finally wrapped in data. Here was a planet orbiting a sun not so different from ours. Here was a temperature that could allow oceans. Here was an orbit not too fast, not too slow. It wasn't Earth, but it was Earth-ish. It was the modern scientific translation of something ancient. And how curious that we gave it a number, not a name like Elysium or Haven, but a string of characters, Kepler-22b. Perhaps that's what makes it feel so real, not mythic, not symbolic, but quietly, audibly possible. It lives at the intersection of folklore and fact, a myth rewritten in telescope data. In many ways, Kepler-22b is a continuation of an ancient tradition, a new chapter in an old story, where ancient peoples looked to the stars and saw gods, spirits and ancestors. We now look and see habitability indexes, temperature estimates and orbital periods. But the emotional core, that hasn't changed. We are still imagining other worlds as mirrors of our own, still projecting possibility outward, onto the dark, still believing, or hoping, that we are not the full extent of nature's creativity. Even our language hints at it. We speak of alien life, but the word alien simply means other, foreign, unknown. And isn't that how all discovery begins? With the unfamiliar made sacred through attention? Science, in this way, is just our newest form of listening. Kepler-22b speaks not in legend or dream, but in data, a diameter 2.4 times that of Earth, a distance from its star that places it squarely in the Goldilocks zone, a parent star just slightly cooler than our own sun, and a potential, just a glimmer, of liquid water. But before it was numbers, it was a feeling, the feeling of looking up and imagining another home. Perhaps that's the most human thing of all, to see in the stars both a question and a memory, to reach outward and inward at the same time, to imagine not just contact as a kinship. Kepler-22b is not the first world we've imagined living on, and it won't be the last, but it might be the one that finally made ancient intuition feel like modern news. And so, even if we never set foot there, even if we never send a ship or hear a sound, it has already become part of us, a new star in the constellation of human imagination. From firelit stories to telescope whispers, we have always listened to the sky, and now, across the vast hush of space, something echoes back. So what exactly is Kepler-22b? At first glance, it's a small blue dot, tucked into a star field in the constellation of Cygnus, the Swan. Barely a glimmer, really. Just one among thousands of potential planets spotted by the Kepler Space Telescope during its quiet vigil between 2009 and 2018. But to astronomers, it was something rare, something promising. A whisper of possibility floating 600 light-years from Earth. Kepler-22b was the first confirmed planet discovered by the Kepler mission to orbit within the habitable zone of a star similar to our Sun. That sentence might sound technical, but what it really means is, This planet could just maybe support liquid water, and where there's water, there's the chance, however slim, for life. Let's start with the basics. Kepler-22b is what scientists call a super-Earth, a planet larger than Earth, but smaller than gas giants like Neptune or Uranus. It's estimated to be about 2.4 times the diameter of our planet. So imagine Earth, and then imagine it stretched out slightly, like a blue marble viewed through a magnifying glass. We don't yet know its exact mass, which makes determining its composition tricky. Is it rocky, like Earth, or gaseous, like a mini Neptune? Some models suggest it may have a thick atmosphere, heavier than ours, or perhaps a vast global ocean with no land at all. A water world, a planet of endless waves churning gently under a pale sun, and that sun, its host star, is quietly familiar. It's a G-type star, just like ours, slightly cooler, slightly dimmer, but still warm and steady. The kind of star you could build a calendar around. Kepler-22b orbits this star once every 290 days, close enough to receive about 90% of the sunlight Earth does, so if you were standing on its surface, assuming it had one, you might see a sky not so different from ours. Just a little softer, the shadows longer, the daylight tinged slightly golden. Now, here's the delicate term that gets scientists excited: habitable zone. It sounds dramatic, but it's really quite simple. Every star emits energy. Too close to it, and a planet bakes, like Mercury or Venus. Too far, and it freezes, like Pluto. But between those extremes is a zone that's just right, where the temperature might allow water to remain liquid, at least under the right atmospheric conditions. This zone is sometimes called the Goldilocks zone. Not too hot, not too cold, just right. Kepler-22b was the first Earth-size-ish planet found to orbit in this Goldilocks zone. That's why it made headlines. Not because it proved anything, but because it suggested, whispered, maybe. But let's not get ahead of ourselves. There are still many things we don't know about Kepler-22b. Most of what we do know comes from light, not photographs, not visits, just data, flickers and shadows. Kepler, the telescope, used a method called the transit method to discover it. Imagine watching a bug crawl across a flashlight beam. You wouldn't see the bug directly, but you'd notice the light dim slightly when it passed. That's what Kepler did. It stared at 150,000 stars, watched them closely, and whenever a tiny dip in brightness occurred at regular intervals, it took note. That dip, that was a planet passing in front of its star, just for a moment. A partial eclipse, invisible to human eyes, but detectable with sensitive instruments. That's how Kepler-22b was found, a 0.2% dip in brightness, occurring every 290 days. Over time, the data added up. A planet, a potential orbit, a size estimate, an idea. It's humbling, really, that we can know so much about a world we've never seen, that we can infer atmosphere, temperature, and orbit from tiny changes in starlight. It's a kind of scientific poetry, reading planets in shadows. But even with all that precision, the details are still wrapped in mystery. For example, does Kepler-22b have an atmosphere? If so, what's it made of? Is it thick with carbon dioxide like Venus, or thin and breathable like Earth's? Right now, we don't know. Our telescopes aren't yet strong enough to decode that from 600 light-years away, but they're getting closer. New instruments like the James Webb Space Telescope are beginning to scan the atmospheres of exoplanets using something called spectroscopy, breaking apart light into its component wavelengths, like a prism, to identify gases. Each gas leaves a signature, a chemical fingerprint. One day, perhaps soon, we might get a glimpse of Kepler-22b's atmosphere and finally know whether it could host clouds, rain, or even the oxygen we rely on. But for now we wait. We wonder. And in the meantime, scientists simulate. They build models of the planet based on what little data we have, plugging in variables like mass, gravity, possible greenhouse effects. And many of those models, intriguingly, suggests that Kepler-22b could have a stable climate. That, if it has the right atmospheric pressure and composition, temperatures could range between 15 and 22 degrees Celsius, much like a temperate spring afternoon here on Earth. Not paradise, but peace. Of course, this assumes many things, and science, when it's honest, always admits what it doesn't know. Kepler-22b might be barren, or toxic, or just ever so slightly wrong in ways we can't yet measure. That's the risk of working at such distance. But it's the possibility, the maybe, that keeps us listening. And let's pause here, just for a breath, and consider something else. Even if Kepler-22b isn't habitable, even if it's just a lonely sphere wrapped in clouds or gas, it tells us something essential. It tells us that planets like Earth might not be rare, that habitable zones are not unique to us, that super-Earths are common, perhaps even the most common type of planet in the galaxy. And if that's true, then perhaps life isn't rare either. Perhaps in the vastness of space there are other worlds with air, with oceans, with something like weather, and perhaps even something like wonder. So, imagine we could go there. Let's suspend the physics just for a moment. Let the light years fold like paper cranes, and the centuries melt away. Imagine standing, actually standing, on the surface of Kepler-22b. What would greet you? We don't know for certain. But with what we've learned so far and a little careful science, we can make a few beautiful guesses. First, let's talk about the sky. Because Kepler-22b orbits a star not so different from our own, its sky might feel familiar. The sunlight would be slightly dimmer than ours, softer around the edges, as though dusk and noon had met halfway. Shadows would stretch a little longer, but not eerily so, just enough to make the landscape look thoughtful. If it has clouds, and we hope it does, they might drift slowly, thick and lazy, shaped by an atmosphere we can't yet describe. Perhaps they carry water vapour, perhaps methane, perhaps something we haven't named yet. Their colour might not be white. It could be yellowish, or faintly lavender, or grey-blue with a shimmer we don't yet understand. The horizon might curve differently too, because Kepler-22b is about 2.4 times Earth's diameter. The curvature of the planet would be slightly more pronounced. Hills in the distance might look just a bit steeper. The ground would fall away more quickly than you're used to, as if the world itself is subtly reminding you, this isn't Earth. And then there's gravity. Kepler-22b is bigger than Earth, but unless we know its mass, we can't say exactly how strong its gravity is. If it's rocky and dense, gravity could be significantly stronger than Earth's, maybe 1.5 to 2 times what we're used to. That doesn't sound like much until you try to walk. Each step would feel like a small act of effort, a gentle resistance, not crushing, not unbearable, but present. You might tire faster, you might carry yourself lower, your heartbeat might need a little time to adjust, but eventually your body, as bodies often do, would adapt. Muscles would change, bones would respond, breathing would steady, and you'd look up and realize you are walking on an alien world. Now, if Kepler-22b has a thick atmosphere, it might create a kind of greenhouse effect, trapping heat and creating warm, stable surface temperatures. That could mean misty mornings and balmy evenings. It could mean clouds glowing softly in a violet sunset. It could mean seasons, even weather patterns, though perhaps with rhythms unlike any we've seen before. Winds might be slower or stronger. Rain might fall in long, heavy droplets. Or maybe it wouldn't fall at all, but instead condense and vanish. The physics of precipitation on a super-Earth could rewrite everything we assume about water cycles. We can't say for sure if there's land. It's possible Kepler-22b is covered entirely in water, a true ocean planet. No continents, no trees, just a boundless sea stretching in every direction, stirred by invisible tides and warmed by a sun that never flares too bright. That idea of a planet without land might feel lonely at first, But imagine it differently. Imagine a world where the only thing beneath your feet is the rise and fall of the waves. No borders, no highways, just rippling living water, ancient, endless, blue. You'd live on floating structures, cities made of gentle geometry, gardens powered by sunlight and science. Above you, alien birds, or something like them, circle and cool. Below, vast ecosystems churn quietly in the dark. Life in the ocean would evolve differently, perhaps more slowly, perhaps more freely, perhaps in directions we can't even sketch. Of course, all of this depends on something critical: atmosphere. Without one, Kepler-22b would be as silent as the moon, a ball of rock or water in a vacuum, unbreathable, unprotected. But with the right mix of gases, nitrogen, oxygen, maybe a dash of carbon dioxide, it could be life-sustaining. We know that Earth's atmosphere is about 78% nitrogen, 21% oxygen, and 1% other trace gases. That balance is delicate. Too much oxygen, and fire spreads like gossip. Too little, and brains don't function well. What if Kepler-22b had its own delicate balance? Not quite ours, but livable. Maybe richer in carbon dioxide, making plant life more efficient. Maybe denser, creating higher air pressure and muffling sound. Imagine a world where even loud voices sound like whispers, where thunder rolls slowly, like a drum underwater, where the wind hums instead of howls. We don't know if there are plants, but if photosynthesis is a universal strategy, and it might be, then perhaps alien forests rise there, not green necessarily. Photosynthesis on Earth relies on chlorophyll, which reflects green. But on a different world, under a different star, the dominant pigments could reflect red, or black, or even a soft silvery sheen. Imagine trees with wide leaves like sails. Imagine fungi the size of furniture. Imagine moss that glows faintly when the air is warm. And then, of course, comes the real question. Could we live there? Not in domes, not in suits, but truly live. The answer, as of now, is we don't know, but we're learning what to look for. Scientists are developing models for biosignatures, chemical fingerprints of life. Certain combinations of gases, like oxygen and methane coexisting, can only persist if life is constantly replenishing them. It's like walking into a kitchen and smelling baking bread. Even if you can't see the loaf, you know something is alive in there. So far, we haven't detected a biosignature on Kepler-22b, but we haven't ruled it out either, and even if we don't find life, it doesn't mean we couldn't bring it. That's where terraforming enters the conversation. The idea of altering a planet's environment to make it more Earth-like. It's science fiction for now, but it's becoming science adjacent. Hypothetical steps include warming the planet with orbital mirrors, seeding it with microbes to release oxygen, or building contained ecosystems that slowly expand outward. The scale of such a project? Monumental, but the idea? Purely human. Because we've always altered our environments, from fire pits to farms to cities. Terraforming Kepler-22b wouldn't be a conquest. It would be a kind of courtship, a slow, careful coaxing, a conversation between two worlds, written in science, sweat, and sunlight. And maybe we never get that far. Maybe Kepler-22b is too far, too strange, too quiet. But every time we study it, every time we simulate its air, its light, its spin, we get a little better at seeing not just it, but ourselves. We learn what makes a planet livable, what makes a world feel like home: temperature, atmosphere, gravity, chemistry, and something more, something intangible, the sense that, under the right sky, with the right stories, life could feel right. Because when we say home, we don't just mean livable, we mean meaningful, we mean ours. Kepler-22b might never be that, or it might become the first chapter of humanity's second home. Not a replacement, but a reflection. Not an escape from Earth, but an echo of its possibility, a place to begin again, carefully, kindly, wonderfully. And so we study, we send telescopes and algorithms, we build models and dream in oxygen levels, not because we're certain, but because we're curious, because in a quiet corner of the sky, a star is shining on a world that may, or may not, hold oceans, and somehow that's enough. It invites us to look up, to hope, to wonder, and to remember. We are not just watchers of stars, we are participants in the cosmos. The science of Kepler-22b is only just beginning, but the story has been with us for a very, very long time. Imagine for a moment that beneath the gentle shimmer of distant starlight, Kepler-22b pulses with the hidden rhythms of a world not so unlike our own. In the hushed voice of cosmic possibility, we now turn to the inner workings of this enigmatic planet, a place whose secrets might one day reveal whether it could cradle life. Let us begin by exploring the very mechanism of Kepler-22b. In many ways, a planet is a dynamic orchestra composed of countless interwoven processes. Deep in its core, far below any imagined surface or ocean, lie the echoes of formation, the violent yet creative throes of cosmic birth. Kepler-22b, like our Earth, is believed to have coalesced from swirling clouds of gas and dust around its parent star. In that chaotic early dance, gravity gathered particles together, setting the stage for a rocky core to form and, eventually, for more delicate layers to build upon it. At the centre, pressure and heat may forge a metallic core, a beating heart that generates a magnetic field. A magnetic field is more than a scientific curiosity. It is a guardian, a quiet protector that can shield a planet's surface from the relentless barrage of stellar winds. Imagine standing on a surface where invisible lines wrap around you, deflecting the charged particles hurled by the star, lines that might make the difference between a barren rock and a habitable haven. Although we do not yet have direct evidence of Kepler-22b's inner magnetism, theoretical models often suggest that planets of its class could harbour a significant magnetic field, provided their interior is in a molten convective state. This internal dynamism, however, is only part of the story. The very composition of Kepler-22b defines its nature. Being termed a super-Earth implies it is larger than our own world, about 2.4 times Earth's diameter, but size alone does not dictate habitability. What is crucial is the planetary composition. Is it a robust, rocky body like Earth, or is it more akin to a mini Neptune enveloped in a thick, swathing layer of gas? Some models allow for a solid, rocky mantle, possibly rich in silicates and metals, cradled beneath an extensive atmosphere. Other theories suggest that what we see from afar could be the shimmering surface of a water world, a planet ensconced in a global ocean with little or no exposed land. For those who find comfort in the idea of familiarity, the prospect of a rocky, Earth-like surface is enticing. In that vision, tectonic plates might shift slowly across the surface over immense spans of time, regulating the planet's climate and giving rise to mountain ranges and valleys that echo the quiet majesty of our terrestrial landscapes. These geological processes, though measured in millions of years, are like the slow, deliberate breathing of the planet, expanding, contracting, and reshaping itself in an elegant, inexorable rhythm. Yet, while the inner processes set the stage, the outward face of Kepler-22b is defined by its atmosphere. Here, in the space between the surface and the heavens, the planet's story truly begins to feel intimate. If Kepler-22b possesses an atmosphere with the right balance of gases, a mixture perhaps reminiscent of Earth's, but with a twist that suits its unique conditions, it may well sustain liquid water on its surface. The concept of the habitable zone, so lovingly called the Goldilocks zone, comes into focus here. Being positioned at just the right distance from its star, Kepler-22b receives a gentle but sufficient caress of sunlight to warm its surface without scorching it. Under such conditions, water, if present, can remain liquid, a necessary ingredient for life as we know it. Yet, the composition of the atmosphere is a delicate script written in the language of chemistry and physics. Oxygen, for instance, is not only the breath of life for us, but also a potent marker for biological activity. On Earth, oxygen did not flood the atmosphere overnight. Its slow accumulation was the result of countless microbes performing photosynthesis over eons. On Kepler-22b, if similar processes were at work, the atmosphere might hold traces of oxygen mingled with nitrogen, carbon dioxide, and perhaps even unexpected compounds, a chemical fingerprint hinting at processes both familiar and strange. The mechanisms that mix these gases, winds, storms, and cycles of heating and cooling, are the planet's own way of pulsing with life. The atmospheric dynamics are influenced by Kepler-22b's rotation rate, its axial tilt, and the very nature of its parent star's light. For example, if the planet rotates more slowly than Earth, days might stretch into long, languid periods of light and dark, altering weather patterns in ways we can only dream about in our quiet midnights. A slower rotation could lead to permanent twilight along the borders of light and shadow, perhaps forming enigmatic regions where life might cluster in the gentle balance between extremes. Moreover, the interplay between the planet's surface and its atmosphere is where habitability takes on a tangible feel. Consider the concept of heat redistribution. On Earth, winds and ocean currents carry warmth from the equator towards the poles, smoothing out the extremes of weather. On Kepler-22b, a similar process could operate, if the conditions are right. Atmospheric models predict that if the planet has sufficient atmospheric density, it might effectively distribute heat across its surface, creating a stable, temperate climate even if one side of the planet is more directly bathed in sunlight than another. This delicate orchestration of internal heat, atmospheric dynamics, and solar energy not only hints at the presence of moderate temperatures, but also opens a window into the potential for seasonal cycles, seasons, changes that bring variety to an otherwise steady world might emerge from the tilt of the planet's rotational axis. On Earth, seasons are celebrated as the graceful dance of nature, each one a unique promise. In a similar spirit, if Kepler-22b tilts ever so slightly on its axis, it may experience periods of blossoming growth and quiet dormancy, a cosmic cycle that nurtures life and provides a measure of time and change. Now, let us gently transition our focus to the implications of these mechanisms. If Kepler-22b's interior churns with the vigour of a nascent star, and its atmosphere swirls with the promise of a nurturing veil, then what might that mean for habitability? To understand habitability, we must consider not just the raw components, a rocky core, an inviting atmosphere, an apt orbit, but the symphony they create together. Habitability is, in a sense, a measure of potential, a quiet promise that the conditions might be just right for life, or at least for life as we understand it. It is the notion that, under the right pressure and temperature, complex chemistry can flourish, giving rise to living organisms that find meaning in their environment. On Earth, this delicate balance evolved over billions of years, orchestrated by the unhurried interplay between geology, biology, and climate. The implications for Kepler-22b are profound. Should this world indeed be a rocky super-Earth with a temperate climate, it might represent not just a scientific curiosity but a second chance, an echo of the familiar, calling us to imagine a future in which humanity might expand its reach beyond the cradle of Earth. Imagine, if you will, a future where brave pioneers step onto alien soil not as conquerors, but as gardeners gently coaxing life from a foreign ancient landscape. These future settlers would not simply impose earthly ways on an alien world. They might learn from Kepler-22b's own slow, deliberate rhythms, and in doing so, redefine what it means to live in harmony with a planet. There is also an ethical and philosophical implication in studying a world like Kepler-22b. It challenges us to reflect on our own responsibilities as stewards of life. Here, in our quiet pursuit of knowledge, lies a poignant reminder that Earth too is fragile and rare. The scientific deep dive into Kepler-22b's mechanisms illuminates not just another potential home, but also casts a gentle light on our own blue world, its beauty, its vulnerability, its need for care. Consider, for example, the delicate balance required to sustain a magnetic field. On Earth, our magnetic shield not only protects life from cosmic radiation, but also influences the migration of birds, the navigation of ancient mariners, and the very rhythm of the natural world. Should Kepler-22b possess a similar shield, it may invite not only life but also the evolution of intricate ecosystems that flourish under its protective veil. And if the atmospheric dynamics foster steady, gentle weather patterns, then the stage is set for biological evolution, a slow, intricate ballet of adaptation and survival that echoes the deep history of life on Earth. In the quiet laboratory of cosmic evolution, every parameter, gravity, composition, temperature, pressure, tells a story. These stories are written not in bold headlines, but in soft, lingering observations. The faint dip in starlight that signals a transit, the subtle signature of a chemical compound in a spectrum, the measured pitch of a distant star's oscillations. Together, they compose an epic of possibilities that spans billions of years and countless light years, a lullaby of nature sung in the universal language of science. It is here, in this realm of gentle calculations and grand hypotheses, that we see the real beauty of the scientific endeavour. It is not about certainty, but about wonder. It is about gently prodding the boundaries of the known with questions that lead us to more questions. And in that process, we learn to cherish the mystery even as we seek understanding. For now, our models of Kepler-22b are like tentative sketches, a soft pencil drawing of a landscape that we can only imagine stepping into. But each new observation, each incremental advance in technology, adds detail to that drawing, transforming it from a mere suggestion to a vivid portrait of possibility. So, when we speak of mechanisms and implications on Kepler-22b, we are not merely reciting facts or numbers. We are in essence whispering the promise of renewal, a promise that somewhere out in the cosmic dark, a world may exist that mirrors our hopes and dreams, a world that silently invites us to imagine what life could be, if we learn to listen as carefully to its slow, measured heartbeat as we do to the rhythms of our own. And thus, in this quiet pause between calculation and curiosity, we leave the first part of our deep dive, an exploration of the inner mechanics and the delicate interplay of forces that might make Kepler-22b a haven for life. In the coming section, we will journey further into the anomalies, edge cases, and the unexpected experiments that challenge our assumptions, daring us to imagine even more boldly what this distant world might hold. If you've ever gazed out across the ocean and felt both peace and possibility, you already understand something essential about science. It's not always about answers. Often, it's about standing quietly on the edge of the unknown and staying there just long enough to wonder what might be beneath the surface. That's where we now find ourselves with Kepler-22b. We've explored the mechanisms, orbit, composition, atmosphere, potential magnetism. But what happens when we follow the trail into stranger territory? Into the corners of planetary science where things get fuzzy, where the data is still too thin to support conclusions but too tantalizing to ignore. This is where edge cases and anomalies live. Let's start with something deceptively simple: rotation. We don't know how fast Kepler-22b spins. That alone might not seem terribly important, but the implications ripple outward. On Earth, a full rotation takes 24 hours, giving us our familiar cycle of day and night. But what if Kepler-22b spins much more slowly? Imagine a single day lasting weeks, half the planet basking under an unbroken sun, while the other lingers in long, unrelenting night. This could create tidal locking, a condition where the planet always shows the same face to its star, one side in eternal daylight, the other in permanent darkness. That sounds like a death sentence for habitability, but it's not necessarily. Models suggest that if Kepler-22b has a thick enough atmosphere, it could distribute heat between hemispheres. In fact, a twilight zone might form along the boundary, a ring of perpetual dusk where conditions are surprisingly stable, cool enough to avoid overheating, warm enough to stay above freezing. It's even been called the eyeball Earth scenario, with the sun-facing side a steamy ocean, the far side an ice sheet, and a habitable band circling between. It's a strange thought, that life might emerge not across a planet but along a narrow ribbon of light. Now imagine storms, not the kind we know, but planetary-scale tempests spanning thousands of kilometres. On gas giants like Jupiter, storms can last for centuries. On Kepler-22b, where gravity, rotation and temperature gradients differ from Earth's, we might see slow-moving hurricanes that span entire continents, winds that never cease, cloud systems that pulse like breathing. Would that kind of world feel frightening or hypnotic? Perhaps with time we'd find its rhythm and settle in. Homes built under domes, adapted crops, weather monitoring more precise than any we've known. And then there's chemistry. Not just the kind that forms rocks or rain, but the kind that gives rise to life. The challenge is this. We only know life as it exists on Earth. Carbon-based, water-dependent, temperature-sensitive. But the universe is not required to follow our recipe. What if Kepler-22b hosts entirely different conditions and entirely different biology? Astrobiologists speak of life as we don't know it. Imagine organisms that breathe hydrogen, that use silicon instead of carbon, that rely on ammonia as a solvent, not water. Would we even recognize them as living? It's a humbling thought. Life could be staring back at us, and we might miss it, because it doesn't match our expectations. This brings us to false positives, one of the most delicate edge cases in exoplanet science. When we analyse the light from a planet's atmosphere, we're looking for chemical signatures: oxygen, methane, ozone. Their presence in combination often points to biological activity, but those same chemicals can be produced by non-living processes, volcanic eruptions, lightning, photochemical reactions. A biosignature, in other words, might be a biomimic. That's why confirmation takes time. Scientists must rule out natural geological explanations before suggesting life. It's a slow, careful process, one that teaches us patience and humility. And speaking of mimicry, let's drift now into the realm of mirror worlds. Some researchers have speculated that there might be planets that are nearly identical to Earth in size, temperature, composition, but with reversed rotation, flipped magnetic polarity, or completely alien biospheres. These are sometimes called Earth analogues, or Earth twins. Kepler-22b is not a perfect twin. It's larger, its orbit is longer, and we still don't know its mass. But it's close enough to whisper the idea. What if it's Earth, but older? Or younger? What if we're looking at our own planet in a different timeline? One where evolution took a different path? There's a concept in planetary science called convergent evolution. The idea that similar environments produce similar solutions. On Earth, wings evolved separately in birds, bats, and insects. Eyes appeared in multiple lineages. If the right conditions exist, life finds a way. Could Kepler-22b host forests? Maybe. Animals? Perhaps. Civilization? Unlikely, but not impossible. One of the most quietly thrilling things about studying exoplanets is the sheer number of them. Kepler-22b is just one of over 5,000 confirmed so far, and many more candidates are waiting. The more we discover, the clearer it becomes. Earth is not rare in being a planet. What might be rare is having a planet like Earth that's also stable, complex, and long-lived. But here's something that often gets missed. Habitability doesn't require perfection. It just requires balance. A planet can have a bit more gravity, a bit more carbon dioxide, a thicker crust, or a slower orbit. As long as everything works together, life, or the potential for it, can emerge. Even in extremes, we find resilience. On Earth, life thrives in boiling hot vents, in frozen deserts, in acid lakes. There are organisms called extremophiles that can survive radiation, vacuum, and pressures far beyond what humans can endure. If life can survive in Antarctic lakes and deep-sea vents, it might very well survive on Kepler-22b. Even if the surface is unfriendly, life might exist below it, in subsurface oceans, shielded by ice and warmed by geothermal energy. Europa, one of Jupiter's moons, is a model for this kind of speculation. Beneath its icy crust is a vast liquid ocean. Kepler-22b, if it's a water world, might operate the same way, life forming in the darkness, lit by chemical reactions, never seeing a sky. This brings us to one of the most subtle but profound possibilities. We may already have encountered planets more suitable for life than Earth. Think of it. A planet with no tectonic instability, no extreme seasons, no magnetic field reversals. A planet where climate is stable for billions of years, where storms are rare, where biodiversity flourishes quietly. Wouldn't that be something? And now, the experiments. Every discovery about Kepler-22b has sharpened our tools. Our models are better, our spectrometers more precise. Our telescopes are evolving not just in size, but in sensitivity. We are learning how to read the faintest traces of a planet from light years away. James Webb is already changing the game. Telescopes like the upcoming Nancy Grace Roman Space Telescope, and later LUVOIR or HABEX, will allow direct imaging of Earth-like exoplanets, not just spectra, but actual pictures. We may soon see Kepler-22b as a pale blue dot, not just an inference. In laboratories on Earth, scientists simulate exoplanet atmospheres, recreating alien skies in sealed chambers. They bombard chemicals with ultraviolet light, test microbial survival in harsh gases, and map weather systems on computer models the size of cities. And through all this, a quiet idea takes root. Maybe Kepler-22b isn't our next home because we'll go there. Maybe it's our next home because it changes how we see home, because it makes us realize that Earth isn't special because it's unique. It's special because it's alive. That's the deeper paradox. The more we search for other Earths, the more precious this one becomes. When we dream of Kepler-22b, we're not dreaming of escape. We're dreaming of resilience, of expansion, of understanding. We're asking what it means to be part of a universe where life might not be a fluke, but a natural result of time, chemistry, and sunlight. A few final curiosities while we drift. Kepler-22b is 600 light-years away. That means the light we're seeing left that planet during the early 1400s, around the time Johannes Gutenberg was printing his first movable-type books, a world of parchment, lanterns, and whispered prayers. That light has been travelling ever since. So when you look at Kepler-22b, even just in your imagination, you're not seeing it now. You're seeing it as it was, just as any aliens looking at Earth would see us centuries ago, before planes, before satellites, before the noise. That's the strange grace of astronomy. We don't just study planets, we study time. So what if someday someone looks back at Earth the way we now look at Kepler-22b? Will they see beauty, chaos, harmony? Will they see a place where life tried, again and again, to thrive? That perhaps is the final gift of exoplanet science. It doesn't just teach us about the universe, it teaches us how to care. There's something almost paradoxical about it. We live on a rocky planet hurtling through space at over 100,000 kilometers an hour, tethered by invisible forces to a glowing star 150 million kilometers away. And yet for most of human history, we didn't really know that. We saw the sky as a dome, polished, static, serene. The stars were not distant suns but heavenly pinholes. perhaps stitched into the fabric of the night by gods or ancestors or celestial creatures with a flair for quiet decoration. And why wouldn't we think so? With no telescopes, no satellites, no physics to guide us, only naked eyes and curious hearts, the sky was a mystery best explained by story. Our ancestors named the stars, made shapes out of them, told tales. The sky was narrative, not navigation. But in that very act of looking up and wondering, the long story of exoplanet discovery was already beginning. Though no one could have known it yet, we had already started chasing Kepler-22b. In ancient Greece, philosophers like Democritus and Epicurus spoke of infinite worlds, scattered throughout space. They imagined that some might be barren, others full of life. These weren't scientific theories in the modern sense, more like metaphysical musings, but the seed was there, the idea that Earth might not be unique. Then, much later, came a man with a telescope, Galileo Galilei. In 1610, Galileo turned his handcrafted telescope toward the sky and saw, for the first time, that Jupiter had moons, little worlds circling a giant one. It may seem like a footnote now, but at the time, it was radical. Earth wasn't the only centre of motion. There were other systems, and if moons could orbit Jupiter, could planets orbit stars? The 17th and 18th centuries saw thinkers like Christian Huygens and Giordano Bruno push this further. Bruno, for one, imagined countless stars, each with their own planets, and was eventually burned at the stake, though not just for that. Still, he paid a high price for believing that the universe might be infinite and varied. Slowly, the structure of the cosmos became clearer. Isaac Newton, with his wild mane and apple-fueled mathematics, gave us gravity, the invisible glue that explained why planets move the way they do. Suddenly, the universe had rules, predictable ones. You could calculate a planet's motion not with myth, but with math. Still, even as our own solar system came into focus, Mercury to Neptune, rings to comets, the stars beyond remained stubbornly mute. They twinkled, but they told us nothing about what circled them. We could only guess. Through the 19th and 20th centuries, that guesswork took on a more structured form. Astronomers began searching for signs of wobble, tiny shifts in a star's position that might hint at an orbiting planet's gravitational tug. But the data was inconclusive, the instruments imprecise. Planet hunting, it seemed, was still out of reach. Then, in 1992, quietly, almost humbly, it happened. Two astronomers, Alexander Wolszczan and Dale Frail, announced the first confirmed discovery of planets beyond our solar system. They weren't orbiting a familiar star. Instead, they circled a pulsar, a dead, rapidly spinning star emitting beams of radiation. It wasn't the kind of place anyone expected to find planets. But there they were. The discovery didn't make global headlines. It didn't shift culture overnight. But in hindsight, it was a turning point, the moment the universe began to answer back. Just 3 years later, in 1995, Michel Mayor and Didier Queloz detected a planet orbiting a main sequence star, 51 Pegasi b. This one was stranger still, a hot Jupiter, a gas giant orbiting incredibly close to its star. It wasn't Earth-like, it wasn't habitable, but it was proof. Planets were out there, lots of them, and they didn't always follow the rules we thought they should. A rush followed, an exoplanet gold rush. New techniques emerged. Astronomers used radial velocity, measuring the wobble of stars. Then came the transit method, where planets were detected by the tiny dip in brightness they caused when they passed in front of their stars. Like watching a moth flit across a streetlight, but from hundreds of light years away. It was elegant and astonishingly effective. Which brings us to 2009, the launch of NASA's Kepler space telescope. Kepler didn't go looking for just 1 or 2 planets. It stared at a fixed patch of sky, a quiet, nondescript section of the Ignis Lyra region, and watched 150,000 stars waiting for any to dim, patient, persistent. Over 4 years, Kepler found over 2,600 confirmed exoplanets, more than we had discovered in the entire history of astronomy. Among them, in 2011, was Kepler-22b, the first Earth-size-ish planet orbiting in the habitable zone of a Sun-like star, not a gas giant, not a scorched rock, something quieter, gentler. A whisper that maybe, just maybe, the Earth had a cousin. The announcement was cautious. Scientists avoid hype. But you could hear it in their voices. Something had changed. We weren't just detecting planets anymore. We were detecting places. Kepler-22b isn't the most Earth-like planet ever found. Since its discovery, others have appeared: Proxima Centauri b, TRAPPIST-1d, and more. But it was the first to show us what was possible, the first to make it feel personal. And with that came a flood of new thinking. Scientists began refining what habitable means. It's no longer just about temperature. It's about atmosphere, magnetism, water, chemistry, plate tectonics, even moon systems. All the things Earth has that make it so quietly miraculous. At the same time, our tools improved. The James Webb Space Telescope was designed, launched, and is now actively observing exoplanet atmospheres. With it, we can, for the first time, detect the chemical fingerprints of distant skies. Not guess. See? This is where the history turns speculative. Because now we're not just looking back, we're looking forward. We're beginning to talk about sending probes, about next-generation telescopes that will directly image Earth-like planets, not as points of light, but as tiny disks, showing oceans, continents, weather systems. There's even talk of using lasers to propel tiny spacecraft to nearby stars. Breakthrough Starshot is one such idea, sending gram-scale probes at 20% the speed of light. They'd reach Alpha Centauri in just over 20 years. If Kepler-22b is ever within range, and it's not yet, these are the kinds of missions that would touch it first. And all the while, the public has changed too. We no longer think of planets as exotic. We think of them as inevitable. Every star probably has planets. Many of those planets probably have water. Some of those might have life. This is the arc of our understanding. From heavenly gods to mathematical laws to quiet data points to possibility. It's not just about what's out there, it's about how we've learned to see it. A few decades ago, the idea of an Earth-like planet orbiting a distant star was the stuff of science fiction. Now it's a search field on a NASA database. Kepler-22b is not just a name, it's a waypoint in humanity's journey from wonder to knowledge, from myth to measurement. And maybe, someday, it will be more. A landing site, a classroom, a home. But even if we never go, even if Kepler-22b remains forever beyond reach, it has already done something beautiful. It has reminded us that Earth is not an only child, that stars do not shine in vain, that somewhere long ago a tiny flicker of light left a distant world and found its way into our telescopes and our hearts. The history of exoplanet discovery is not just a tale of technology. It's a story of longing, of patience, of refusing to believe that this tiny rock we live on is all the universe has to offer. And Kepler-22b, silent, slow-spinning light years away, will always hold a place in that story, as one of the first planets to whisper back. Somewhere in the dark folds of space, a planet moves silently around its star. It has no name for itself. It doesn't know it's called Kepler-22b. It doesn't know we're watching. It just exists, steadily, unknowingly, beautifully. And here we are, 600 light-years away, imagining it. We imagine oceans. We imagine rain. We imagine clouds so thick and alien that they bend the light into unfamiliar hues. We imagine the wind and wonder if it howls or whispers. We imagine standing there, our boots sinking slightly into its soil, or whatever strange material counts as ground on that world. And in doing so, we're not just describing Kepler-22b, we're describing ourselves. Because this, in the end, is what we do. We project our longing onto the stars. We ask distant planets to carry the weight of our questions. We look up and somehow see in the abyss not emptiness, but possibility. It's easy to think of space exploration as a technical matter. Rockets, telescopes, data. But beneath all of that is something far more delicate, the quiet, persistent belief that we are not alone in our experience of existing, that life may not be a cosmic accident, that somewhere, beyond the fog of our uncertainty, something else is growing, and this belief, not quite faith, not quite science, but something suspended gently between the two. This is what Kepler-22b stirs in us. It asks us to consider a strange and wonderful idea, that home is not a fixed place, it is a feeling, and maybe, one day, it could be felt somewhere else. There's a deep and often uncomfortable question that arises when we think about planets like Kepler-22b. Why are we even looking? Is it curiosity, hope, arrogance? Are we explorers or escape artists? Do we seek new worlds because we are hungry for expansion, or because we fear what we've done to the one we already have? For some, the answer is simple. Earth is fragile. Climate change, extinction, resource depletion. They paint a future that feels uncertain. And so we look to the stars not as a luxury, but as a kind of cosmic insurance. Others recoil at that. They argue, perhaps rightly, that we should fix this world before we dream of colonizing others. And in that tension, between Earth and elsewhere, arises one of the most profound ethical questions of our time. Are we running away or reaching forward? Perhaps it depends on how we go. If we go to Kepler-22b as conquerors, trying to tame it, extract from it, shape it into something familiar, then we're running away. But if we go to it as learners, as guests in the house of another planet, then maybe we're not escaping Earth at all. Maybe we're honouring it, bringing its stories to a new chapter, because in the end there's a quiet truth. Wherever we go, we carry ourselves with us, our questions, our contradictions, our capacity for wonder and waste alike. Kepler-22b, for all its distance, doesn't erase that, but it might reflect it. In philosophy, there's an idea called the anthropic principle, the notion that we observe the universe the way we do because we are the kind of beings who can observe it. It's a tautology in some ways, but it leads to interesting speculation. What if planets like Kepler-22b aren't rare? What if the universe is teeming with life, not just single-celled organisms, but civilizations, songs, silence, and if so, why haven't we heard anything? This is the Fermi paradox whispered through the halls of every observatory. If intelligent life is common, where is everybody? One answer is silence, another is distance, another is timing. Maybe civilizations flare up like fireflies and vanish before they can connect. And yet another possibility. Maybe they're listening too, just like us. Maybe there's someone on Kepler-22b, or a world nearby, staring at our sun and wondering, is anyone out there? The loneliness of space is not just physical, it's existential. We want not just to survive, we want to be seen. That's why the idea of settling another world is so potent. It's not just about life support and oxygen, it's about narrative, about continuing the story of humanity beyond Earth's borders. But here's the twist. The farther we look, the more we realise how improbable our own story is. Earth isn't just habitable, it's perfectly balanced. Just enough water, just enough carbon, just the right distance from the sun, a magnetic field, a large moon that stabilises our tilt, a planet-sized protector in Jupiter, sweeping away comets, 1,000 variables, each balanced delicately. So when we say Kepler-22b is habitable, what we really mean is that it's not impossible. It's a maybe, a shimmer. And still, that shimmer is enough. because the universe does not owe us another Earth. If anything, it has already given us a miracle. And our response to that miracle, the gratitude, the curiosity, the desire to understand, might be what truly defines us as intelligent. Here then is another question. Is humanity meant to stay on Earth? It's a strange phrase, meant to. It implies intention, design. But even if you strip away religion and destiny, something remains. The awareness that humans are restless by nature. We crossed deserts. We built boats and sailed across oceans we didn't understand. We climbed mountains simply because they were there. We made wings, we made maps, and now we make star charts. We may be the universe's way of knowing itself, or we may just be temporary flickers in a much larger pattern. Either way, we reach, we listen, and Kepler-22b gives us something to listen for, even if we never reach it. Even if it's just a planet with clouds and silence, it has already changed us, because it asked us to imagine life beyond our narrow blue shoreline. And that act of imagination, that stretch, is its own kind of evolution. In science fiction, planets like Kepler-22b are often backdrops for adventure. New worlds to settle, new frontiers, but in the soft science of sleep we can ask gentler questions. What if we don't go to change it? What if we go to meet it, to let its conditions shape us, to evolve over generations into something new? Homo kepleriensis, perhaps, a species still human, but coloured by new seasons, new stars, new stories. What would art look like on a world with 300-day years? What would music sound like, written in the pressure of a different sky? What philosophies would emerge from a civilization raised not under Earth's moon, but under an unfamiliar constellation? Kepler-22b in this sense is not a destination. It's a mirror, a thought experiment, a quiet space in which to imagine who we might become, if we were given time and distance and another chance. And here's something quietly beautiful. Even if no one's there, it's still beautiful. Even if it's just rocks and gas and wind, it still matters. Because the act of noticing it, that flicker of light, that wobble in a star, that tells us something essential. It tells us that we are watching and that we care. And maybe in a universe where so much is silent, that act of care is a kind of answer in itself. It says, we are here. We don't know if we'll ever reach you. We don't know if you can host our kind of life. We don't even know your real name, but we see you and we imagine you. And that is something. As Carl Sagan once wrote, for small creatures such as we, the vastness is bearable only through love. Maybe Kepler-22b isn't about science or survival. Maybe it's about love. The quiet, expansive love of wondering what else the cosmos holds. The tender curiosity that makes us look up, even when there's no answer. The kind of love that makes you whisper goodnight to a world that has never heard you. So tonight, as you lie in your own little corner of the earth, breathing the air that trees kindly exhale, think of that other world, spinning softly, silently, not waiting for us, but existing all the same. And maybe that's enough. If you're listening to this, there's a good chance it's night where you are. Maybe the lights are dimmed, maybe your phone is perched gently on the edge of your pillow, maybe your ceiling has become a temporary sky, and maybe, just maybe, you've already started imagining what it might be like to fall asleep beneath a different one. Because Kepler-22b, while 600 light years away and far beyond our reach, has already found a way to live inside us. Not physically, of course, not through transport or habitation, but through something more subtle, more intimate, through the way it shapes our dreams. In a culture full of speed and noise and constant light, the very thought of another planet, a quiet one, a distant one, can become a kind of refuge, a mental room with no clocks, where pressure lifts and gravity feels negotiable. And this is not just romanticism, it's reflection. because what we choose to imagine tells us something real about what we feel we're missing. So let's start close to home, with the everyday, with how the idea of Kepler-22b, or any second Earth, seeps quietly into our routines. You wake up, you stretch, you make coffee or tea. And somewhere between checking the weather and swiping through news or messages, there's this sudden contrast. Your world is small, your apartment, your bed, your body, and yet you're aware of a planet hundreds of trillions of kilometers away. That awareness changes you, even if just for a moment it shifts your perspective. The problems that seemed monumental before, emails, traffic, unfinished tasks, shrink slightly beneath the weightless curve of another sky. This doesn't mean our lives are unimportant. Quite the opposite. It means they're part of something bigger, and in that shift there is relief. Kepler-22b gives us a soft kind of escape, not from our responsibilities, but from the illusion that our current world is the only one that could ever matter. It also gives us contrast. On Earth, we complain about rain, cold, heat, seasons too long or too short. But when we think about a world like Kepler-22b, we realise what a luxury it is to even notice the weather, because that means we're alive, breathing, here. Even simple pleasures gain new texture. Standing barefoot in grass, hearing birds at dawn, drinking water from the tap. These are all small miracles made possible by a planet that happens to be just right. And so, the idea of a second Earth is not just about finding a replacement, it's about enhancing the reverence we feel for the first. There's also something curious happening in culture, in movies, television, art. Planets like Kepler-22b are everywhere now, not always by name, but in spirit. They appear as distant refugees, terraformed utopias, or post-apocalyptic escape plans. We build whole genres on them. Sci-fi survival dramas, space travel epics, slow cinema about interstellar colonization. Why? Because deep down, we're reckoning with a difficult truth. Earth might not always be enough. That's not a statement of despair, it's a whisper of evolution. In relationships, this whisper shows up in the way we talk about starting over. We dream of cabins in the woods, off-grid havens, island homes. But the idea behind them is always the same, a desire for reset, for simplicity, for space. Kepler-22b becomes the cosmic version of that, the furthest possible fresh start, a planet untouched by traffic, by ads, by history. And maybe that's why it touches something so deeply human, our longing for innocence. Of course, we carry ourselves with us wherever we go. There's no perfect world waiting to be discovered, only different conditions waiting to be interpreted. But imagining Kepler-22b still offers a kind of psychological balm. It says, even if this world is complicated, there are others. You're not trapped. And that belief has emotional weight, because so much of anxiety, of depression, of existential fear stems from the feeling of being cornered, stuck, unable to leave the page you're on. But Kepler-22b is a bookmark, a signal that says, this story has more chapters. In education, the ripple effect is gentler but steady. Children learn about exoplanets earlier now. Posters show them colourful orbs with impossible clouds, labelled with strange designations like TRAPPIST-1F or LHS 1140b. The result? A generation that grows up thinking of planets as normal, not sacred, not singular, just part of the furniture of space. That changes how we dream. It changes how we measure possibility. It changes who we think we are. Because for much of history, humans believed they were at the centre of everything. Then we learned we orbited the sun. Then we learned our sun was one of billions. And now we know many of those stars have planets too. Some of them may be like ours. Each revelation is a soft dethroning, but also an expansion. We are smaller than we thought, but the canvas is so much bigger. Spiritually, this shift touches even the most secular of hearts. You don't need religion to feel awe, to feel reverence, to feel the holy weight of knowing that somewhere, Light is falling on another world's ocean, and we can't see it, but we can imagine it. That too is a form of belief. That too is culture. Kepler-22b is the cathedral we haven't visited, but still somehow pray toward. And that prayer sounds like a question. What does it mean to be human in a universe so wide? At dinner tables, in casual conversations, you'll hear versions of it. Would you ever leave Earth if you had the chance? Do you think there's life out there? Would you live on Mars? These aren't just hypotheticals, they're identity tests. They tell us how adventurous someone is, how rooted, how hopeful, how afraid. Even comedy has gotten in on the game, poking fun at billionaire space programs or the idea of gentrifying other planets. There's something very human about that too. We laugh when we're overwhelmed, we joke when the truth is too large to hold, and yet under the laughter there's always the hum of sincerity. We do wonder. And so Kepler-22b lives in us, not just as data, but as symbol. It appears in poems, in song lyrics, in video games, in the vague daydreams of office workers who stare out the window and imagine a bluer sky. It shows up in quiet decisions too. The person who chooses to study planetary science because of a childhood book. The artist who paints alien landscapes to soothe anxiety. The insomniac who finds comfort in space documentaries, letting the thought of distant planets lull them to sleep. In this way, Kepler-22b has already influenced culture, not through conquest or colonization, but through intimacy. It has become part of the bedtime story we tell ourselves about what's possible. And bedtime stories, as you know, are powerful. They shape our dreams. And here's the loveliest twist of all. Kepler-22b affects our culture without ever needing to know we exist. It doesn't emit signals. It doesn't invite us. It doesn't respond. It just orbits. And in doing so, it lets us do the dreaming. Because this is the hidden beauty of distant planets. They give us permission to imagine without expectation. They don't owe us anything. They just are. And in their being, they open space for us to think bigger, slower, softer. So whether or not we ever go there, whether or not we ever confirm oceans or forests or even rocks, whether or not it's a place we could breathe, Kepler-22b has already become part of our inner lives. A piece of cultural furniture, a quiet guest in the room, a whisper we carry between breaths saying, "There is more. You're not alone. The story isn't over." So next time you walk your dog, or fold laundry, or sip tea near a window, try this. Picture another version of you doing the same thing on Kepler-22b. Not necessarily because you believe in multiverses or reincarnation or parallel lives, but because imagining someone else feeling something you're feeling, 600 light years away, is a quiet act of empathy. And empathy is culture too. Empathy is connection, even across space. Even in silence, even in sleep. Let's play a game of what if. No stress, no rules, just a thought experiment, the kind that unfolds like a blanket and wraps softly around you. Close your eyes, or just soften your gaze, and imagine it's 1,000 years from now. A ship leaves Earth, its engines humming low, its course set for Kepler-22b. You're not on it. But someone is. Maybe it's your descendant. Maybe it's a synthetic explorer. Maybe it's no one, just a swarm of sensors gliding silently through the void. And after decades or even centuries it arrives. What does it find? A blue world shimmering like Earth once did? A quiet rock stillborn and silent? Or something else? What if it finds ruins? What if it finds a city, abandoned, alien, ancient? What if Kepler-22b wasn't just a future for us, but someone else's past? The idea that intelligent life might have once existed and vanished is not new. We call it the Great Filter hypothesis. It's one answer to the Fermi paradox. Why, in a galaxy teeming with planets, haven't we heard from anyone? Maybe civilizations burn out. Maybe they go quiet. Maybe they ascend or retreat or collapse. Maybe they hit a wall they can't get past. Climate, war, boredom, and disappear before they can make contact. And so maybe Kepler-22b was once alive, teeming, advanced, a place of music and math and meals shared beneath unfamiliar stars. But now, a monument, not to tragedy, but to time. And so we wonder, if we settle there, are we beginning something new, or continuing something long forgotten? Science fiction often plays with this loop, the twist ending where the alien world turns out to be our own, far in the future. The lost colony rediscovered, the DNA match found in the soil, because time, in the cosmic sense, is strange. On Earth, we think of time as linear, clean. Past leads to present leads to future. But in space, especially at scale, time becomes pliable. It bends, it stretches, it folds. A beam of light leaving Kepler-22b takes 600 years to reach us. That means what we're seeing now happened when the Ming dynasty still ruled China, when Leonardo da Vinci hadn't yet painted the Mona Lisa, when telescopes didn't exist. So in a way, Kepler-22b lives in the past, and yet it's also ahead of us, in dreams, in planning, in our imagined future. It sits at a crossroad of time, a planetary paradox. What if, here's another, our arrival there triggers a loop, a bootstrap paradox like the ones in time travel stories where the cause and effect blur into each other. We settle Kepler-22b, and in doing so, we plant the seeds of myths. Myths that, thousands of years later, send people looking for Earth again, back and forth like a cosmic echo. This isn't just fiction. It's a way of stretching our imagination across dimensions. What if Kepler-22b isn't even in our universe? Here's a wild thought. Multiple worlds theory. The idea that for every decision, every quantum fluctuation, a new universe branches off. In some, you turned left instead of right. In some, Earth never formed. In some, Kepler-22b is the birthplace of humanity, and Earth is just a footnote. It's speculative, yes, but not meaningless. Because what it asks us to do is widen the lens, to think not just about our planet and another, but about the entire web of possibility. In one version of events, Kepler-22b is a quiet failure, barren, disappointing. In another it's paradise. In another it's worse, unreachable, unwelcoming, forbidden. And in still another it's our future, fully built, fully lived in. A place with cafes, gardens, poems written in languages no one on Earth ever spoke. What would society look like on such a planet? With 290-day years and possibly longer nights? Would time feel slower? Would sleep cycles adapt? Would generations pass more gently? Would we still call them years? Maybe we'd find a new rhythm, a new clock. One tied not to Earth's sun, but to Kepler-22b's gentle orbit. And maybe, in time, we'd forget where we came from. Earth would become legend, a sacred word in children's lullabies. They'd point at our sun in the sky and say, that's where our ancestors were born, before the crossing. And in that forgetting, we'd become something else, not earthlings, not aliens, just people, with different myths, different mistakes, different music. Science fiction often wonders what it would be like to meet aliens. But what if the real sci-fi twist is simpler? What if we become the aliens? What if the very act of living on Kepler-22b, adapting to its gravity, its air, its isolation, changes us? Over centuries our bodies might evolve, our minds might too. And somewhere down the line, the idea of returning to Earth might feel as strange as the idea of leaving it once did. This isn't about abandoning our past, it's about honouring it, by evolving beyond it. Here's another paradox. Kepler-22b might be more Earth-like than Earth someday. If Earth continues to warm, if oceans rise, if ecosystems collapse, then Kepler-22b, quiet, untouched, might hold a version of stability we've lost, a place to remember what balance feels like, and yet, We don't know what's there. That's the sci-fi mystery at the heart of this. We're dreaming of a world we've never seen. No photos, no smells, no sounds, just a faint dip in starlight, just a whisper of maybe. But isn't that always how the future begins? With shadows, with dreams, with small signals sent through the dark, hoping to land somewhere kind. There's something beautifully ironic about all this. We spend billions on telescopes, on simulations, on missions, and yet the first real trip to Kepler-22b will always be imaginary. It happens in your mind, right now as you picture it. The way light falls on its oceans, the way clouds roll across its alien sky, the way silence might sound there. This is the soft power of science fiction, not to predict, but to prepare, to stretch the imagination just enough that, if the future arrives, it doesn't feel quite so foreign. So let's keep going. What if Kepler-22b has life, but it's not intelligent, not cities, not language, just fields of motion, organisms that shimmer, float, fold? Would we still go? Would we leave them be? Or would we try to communicate with music, with math, with art? What if we can't? Would we still try? What if the planet rejects us, not with malice, but with mismatch? Too much gravity, wrong kind of bacteria, toxins we never anticipated. Would we adapt or move on? Would we terraform, change the planet to suit us, or let it teach us how to change? These questions are not just academic, they're ethical. They ask us what kind of species we want to be. Are we gardeners? Are we guests? Are we invaders? Even in fiction, that question lingers. In The Left Hand of Darkness, in Arrival, in Interstellar, in The Dispossessed. Stories about space are rarely just about planets. They're about people, about choice, about the tension between longing and responsibility. And so, in this sleepy corner of the cosmos, we come full circle. Kepler-22b is real, but our relationship with it? That's still science fiction. And that fiction, tonight, is a kind of lullaby. A gentle reminder that our minds can travel far beyond the reach of our rockets. That dreaming of other worlds isn't childish, it's preparatory. That what if is not a waste of time, it's the first step in any real progress. So go ahead, imagine stepping off a shuttle, the sky above you unfamiliar, the air cold but breathable. You kneel down, you touch the ground, you press your palm to the dirt, real, solid, alien, and for just a moment, it feels like home. Not because it is Earth, but because it reminds you how precious Earth was, and how extraordinary it is to hope for more. That's the power of what if. It's not an escape, it's a return to imagination, to empathy, to curiosity, to you. Maybe Kepler-22b isn't a planet, not just a planet. Maybe it's a lullaby, a question, a mirror, not made of glass or light, but made of possibility. When we first began, we started softly, asking what it might mean to call another world home. We whispered through transit data, atmospheric modelling, planetary rhythm. We dreamt through dust and data, science and silence. And now, on the other side of that long, slow arc, we arrive, not at answers, but at something gentler, a feeling. Because the truth is, we haven't gone anywhere. We're still here, still on Earth, still listening. But in some quiet way, just by imagining we've already been there, to Kepler-22b, to the shores of a hypothetical ocean, to the edge of alien dawn, to a field of blue under a star we've never seen, but already love. Let's pause there. Because that word, love, it doesn't come up often in scientific language. Equations have precision, missions have funding, papers have peer review, but love? That belongs to poets, to children, to those half asleep between dreams and dawn. And yet, what else could describe the feeling of searching the sky, again and again, for a dot of light that might one day say, Yes, that is love, patient, devotional, impossibly vast, and not always returned. So what have we learned? We've learned that Kepler-22b is real, a super-Earth orbiting in the habitable zone of a star not so different from our own. We've learned that it might have water, might have clouds, might have a sky so unfamiliar it would change how we name colours. We've learned that it's not alone, that there are thousands of planets like it, each one quietly spinning, each one whispering, "You're not alone in your aloneness." We've learned that what makes Earth habitable, gravity, atmosphere, magnetism, sunlight, is both rare and repeatable, that the universe seems to know the recipe, but adds different spices every time. We've learned that habitable doesn't mean easy, or safe, or welcoming, it means possible. And sometimes, possible is enough. But beyond the data, the definitions, the spectroscopy and simulation, we've remembered something else, something soft and deeply human, that every scientific discovery is also a philosophical one, that when we find a new planet, we also find a new version of ourselves, more curious, more humble, more patient, more willing to admit how little we know and how much we hope. Because Kepler-22b is more than numbers, it's a reflection of us, of our desire to reach without destroying, to learn without conquering, to imagine without expectation. It reminds us that space is not just out there, it's in here, in the space between thoughts, between breaths, between the known and the unknown. And in that space we rest, we reflect, we return to metaphor. Remember, at the very beginning, we said maybe time wasn't a river, but a mirror. Well, maybe planets are mirrors too. Maybe Kepler-22b shows us what we could become, not in distance, but in character. A world not defined by ownership, but by observation, by awe, by care. Maybe it doesn't matter whether we ever go. Maybe what matters is that we wanted to, that we imagined the long voyage, the strange weather, the soil unfamiliar to human feet, and still felt wonder, that we could love something so far away, that we could feel kinship across space, that we could look up through the atmosphere that cradles us and whisper goodnight to a world that may never answer, that we could do all that and still wake the next day, water our plants, call our friends, care for this planet too. Because maybe Kepler-22b doesn't replace Earth. Maybe it teaches us how to love it better. Knowing that other planets are possible doesn't make Earth less sacred. It makes it more so. The one we know, the one we breathe, the one where we made art and mistakes and laughter and fire. So let this be the paradox we rest with, that by dreaming of another home, we remember how rare this one is, and in remembering, we protect it, not out of fear, but out of gratitude. Kepler-22b will go on spinning. Long after this episode ends, long after we sleep, long after every word we've spoken fades into memory, it will spin, quietly, softly, maybe waiting, maybe not, maybe watching, maybe not, but always there. A gentle point on our map of meaning, a soft star around which our dreams now orbit. So here, at the edge of imagination, where science folds back into silence, let us pause, let us breathe, let us feel the curve of this moment, not as conclusion, but as invitation, to keep wondering, to keep caring, to keep imagining what else might be possible in a universe where a planet like Kepler-22b exists, and where people like us can care about it, even from here, even from bed, even from a small blue world that for now is still home. So, where are you now? Still in bed? Still listening? Maybe you've drifted a little. Maybe your thoughts have wandered across light years and oceans, across clouds and numbers and ancient starlight. Maybe you're still awake, or maybe you're halfway to dreaming. That's okay. That's what this is for. Before we end, let's come back to where we began, to the quiet, to the breath, to the question we didn't quite ask out loud, but maybe you felt it. Not just, what if Kepler-22b is our next home, but something gentler. What if home is something we carry in us, something we share across time, across distance, across stars? If this gave you even a moment of peace, if it slowed your thoughts, softened your pulse, stretched your perspective, I'm so glad. That's why I'm here. That's why this channel exists, to hold a little space for wonder, for science, for sleep. So thank you. Thank you for trusting me with your attention, your stillness, your time. Thank you for letting a distant world lull you gently toward rest. And whether you're listening from a city lit up with blinking signs, or a quiet village where the stars still speak clearly, whether you're young or old, hopeful or heavy-hearted, I hope this journey reminded you, you're part of something vast. You're made of the same atoms as stars, and someone, somewhere, is dreaming beside you. So, until next time, sleep well, fellow traveller, wherever and whenever you are. Good night,